Hi, I am Clayton Jan Delverio, and I will show you how to derive the velocity of a satellite. There are three types of satellite: LEO, which is the lower Earth orbit; MEO, which is the medium Earth orbit; and GEO, which is the geosynchronous orbit. So, let's begin. So, we have a planet here and a satellite here. We call this planet M1, and we call the satellite M2. The satellite has the orbit around the planet. So, from Newton's law of universal gravitation, Fg, and here, from the satellite, Fg. So, Fg from the planet and the satellite are equal in magnitude, but opposite in direction. So, Fg is just equal to Fg1 and Fg2. Because M2 is moving on a circular path, we call M2 as Fc, or centrifugal force. So Fg is equal to Fc, where Fc, using the second law of Newton, which is M is equal to A, and A is equal to V squared over R, because acceleration of an object moving on a circular path is this formula. So we come up with the formula of Fc, which is M2 V squared over R. For Fg, which is here on Earth, Newton's law of universal gravitation is applied. So Fg is equal to G M1 M2 over R squared. Fg is equal to Fc. These two equations, Fg, which is G M1 M2 over R squared, and Fc, which is M2 V squared over R. These two equations are equal with each other, but opposite in direction. So, summation of forces along x is equal to 0 or y. Then Fc minus Fg is equal to 0. So Fc is just equal to Fg. Then we substitute these equations to this. So we have M2 V squared over R is equal to G M1 M2 over R squared. So we look at both sides. We have M2 here and M2 here, and R and R squared. So we cancel out R and M2 on both sides. So V squared is just equal to G times M1 over R. Square root both sides. Then we have a formula: V is just equal to the square root of G times M1 over R. Note that the mass of the orbiting object, or M2, here M2, is not in the equation, which means the velocity of M2 is not dependent on its mass. So the velocity of the object is only dependent on M1. So this equation, R here means two things, which is R is equal to R plus D, where R is equal to the radius of the Earth. which is equal to 6371 kilometers. And D is the distance between the Earth and the satellite. So, we get our final equation. Here, V is just equal to the square root of G times mass of the Earth over R, which is the radius of the Earth, plus D, which is the distance between the Earth and the satellite. So how do we know the distance of a geo-orbit? First, we re-evaluate our equations. So Fg is just equal to Fc, which is G m1 m2 over r squared is equal to m2 v squared over r. So cancel. So G m1 over r squared is equal to v squared over r. So if we want to find out the distance of the geo-orbit, we must first find its velocity. So by rearranging the formula of the velocity, which is v is equal to d over t, so where d is equal to the circumference of the orbit, or which is 2 pi r, and t is the period or time. So we have v is equal to 2 pi r over t. So in this equation here, we see that it is v squared. So we squared this out. So we have 4 pi squared r squared over t squared. Then we substitute v squared over to this value, and we have g m1 over r squared equal to 4 pi squared r squared over t squared times 1 over r. By multiplying this equation by r squared, we cancel r squared here, here, and here. We get the equation G m1 is equal to 4 pi squared over t squared times r cubed. So by multiplying this both sides by t squared over 4 pi squared and t squared over 4 pi squared cancels out, we have r cubed is just equal to g m t squared over 4 pi squared. And this formula actually we already have the formula for solving the distance between the geosynchronous orbit and the Earth. So G is just equal to 6.67 times 10 to the negative 11, while mass of the Earth is just equal to 5.97 times 10 to the 24. So what is T? T is just equal to 24 hours. So we convert that to seconds. We have 60 times 60 seconds and 60 minutes. So we have times 24. So T is just equal to 60 times 60 times 24. So we have 8,600 seconds. So we have all the constants we need. So we rewrite our equation. R is just equal to the cube root of G M T squared over 4 pi squared. So we substitute our constants, cube root. So G is 6.67 times 10 to the negative 11, while M is 5.97 times 10 to the 24, and T is 8,600 seconds over 4 pi squared. So R is just equal to this is squared. So if we calculate this, we have 6.67 times 10 to the negative 11 times 5.97 times 10 to the 24 and times 8,600 squared over 4 pi squared. And this is 42226,910.18 meters. And this is not yet the distance from because it has the radius of the Earth. So by solving the distance from the Earth to the satellite, from M1 to M2, we subtract the radius of the Earth, which is here, R, which is 6,371 kilometers. So R D, so R, which is D, RD is just equal to 42226,910.18 meters minus 6,371 times 10 to the power of 3. So RD is just equal to 4226910.18 minus 6371 times 10 to the power of 3. So we have 35855,910.18 meters or 35,855.91 kilometers, which is the distance from the Earth to the satellite. And that concludes my discussion. Thank you.